Thank you, everyone, for time. Yes. So that I think there's a bit of mix-up in the bill, but that's kind of what I was going to talk about. And when I sat down to think about what I'm going to talk about this afternoon, I thought about all the things I'd talked about over the last few years. So I've been with this conference maybe 6 years. Last year and the year before, I was joined by my colleague or friend and customer, actually, David Mitchell, who's over there, who has the world's first dynamic HVAC system in a GMP space at Cambridge that we built to develop the technology. So that technology exists. So we talked about it last year, we talked about the year before, and then before that, I talked about air change rates. We heard a lot about that as well. And I thought, well, I don't want to talk about the same thing again, honestly. Or we could talk about it, but it's kind of like I want to open up and have a different conversation, okay? So we're not going to talk about that. Well, we're going to talk about something that's related to that a little bit. We're going to talk about, what I'd like to talk about, is why are we not more awesome in clean room innovation? Okay? Because all the things we talked about, air change rate reduction, we did an experiment back in 2011, 13 years ago, that looked at the relationship between air change rates and other important factors, and it was shown that air change rates are not that important. There are other factors at play that we need to control, and therefore that led on to, well, if they're not that important but we need some air change rates, can we make it dynamically and then adapt it for the particular situation? Turns out you can do that, but not a lot has changed in 13 years. We're still having the same conversations around things. So I'd like to kind of explore that a little bit with you today and talk about some things and suggest some perhaps different ways of looking at things. And I'd be really interested in your input because it's the first time that I've done this in this way. So we are experimenting. So that's me. Been around the industry for a fair bit, done lots of things. So I work with, and my team work with pharmaceutical businesses primarily all around the world, helping them to optimize, deliver sustainability by optimizing clean rooms and manufacturing processes and all the difficult kind of stuff to do in the GMP spaces. So I thought, okay, if I'm saying at the start, why aren't we more awesome in innovation in clean rooms particularly, let's kind of look at what's happened over the last kind of decade, right? And compare it with other industries. So, not very scientific, I know, but I asked ChatGPT to list me out all the innovations in the electronics industry, or the top 20 innovations in the electronics industry in the last 10 years. Right? I'm not going to read them out, but you can see a lot of things there. You'll recognize some of the stuff. A lot of that touches our lives right now. Huge innovation in electronics and that kind of industry. Lots of it's really rapid. We know that. Pharmaceutical industry is really innovative as well. There's lots of great stuff happening in the pharma industry. AI is kind of impacting more recently, but there's some fantastic technologies and fantastic innovations that are really impacting people's lives now. And I did the same for clean rooms. And I had 7 things. And when I looked through that, I thought, enhanced disinfection cleaning technologies, yes, no doubt. COVID led to some advances in that area for sure. Clean room robotics, Derek was mentioning that, and developments in that. Smart monitoring and controls, yeah, we're doing some work in that and have done some work in that. Filters, well, not that much a change in filters as far as I can tell in the last 10 years. clean room garments, yeah, there's been some advances, but they've been kind of continuous improvements, right? Continuous improvement, incremental steps, not anything particularly dramatic, I think, but you might have a different view, and that's okay. All of those innovations, if you think about it, required lots of teams of people to innovate and solve problems, right? To think about things, solve problems, do experiments, test, fail, and eventually they'll find a success and some of those technologies come to fruition. So, though that kind of process of problem solving, and there are different types of problems, right? There are simple problems. You know, I can't read from this distance, I need to wear glasses. Okay, and that I've problem solved, I've gone and got myself some glasses. That's a really simple problem. But there's some different types of problems. So, and you think about there's a lot of complexity. So, a question for you, I'd like a show of hands. Of those two items, rocket, spaceship, and a baby, which one, well, let's say this, so who thinks, show of hands, the rocket is complex? Put your hands in the air. Okay, well, I can't count you, but, you know. Okay, who thinks the baby's complex? A lot more of you. Great. The majority of you are right, of course, because the rocket is complicated. There are lots of moving parts, right? There's lots of things that we put together, but we know, because we do science and engineering and we understand physics and all of these things, if we control the inputs to that, we will get the output, which is a rocket that goes into space. Because we understand the relationships and we can control the inputs. Stuff happens, rocket ships, challenges blow up, that's okay. But when they tracked it back, they understood they didn't control the inputs, so the output went a bit awry. So rocket ships are complicated. Babies are complex because we don't know, we can't predict the outcome from the input. You know, we can't predict whether this baby will be a top scientist who's going to invent the cure to cancer or a criminal that's going to defraud loads of people. And we can't predict it. It's really complex. Okay, so that's how are we doing for time? Okay. So, complicated, complex. First concept to think about. So, when we look at clean rooms, what we see and then what we know about clean rooms, we see a lot of stuff, right, in terms of the clean rooms. You know, we've talked about some of these over the last 2 days, I'm sure, you know, design of clean rooms, right? That's complicated, right? We know how to design clean rooms. We know all the elements that go together, and if we put them together in the right way, it's complicated, a clean room, when you look at it. We understand ventilation effectiveness. We understand air change rates and the impact because we've done the experiments. We understand all that, and we understand the relationships between stuff. So this is physics, it's engineering, it's very predictable, actually. Very predictable clean rooms. So, but there's a lot of stuff under the surface, iceberg, that we don't see, I don't necessarily understand. So, a lot of this, so, you know, stuff that relates to attitude to risk, you know, if we want to innovate, a lot of people say, oh, I'm not very clear at that. FOBF. Anyone know what that stands for? fear of being first with stuff. Is this resonating with a lot of you? Fear of change, avoiding uncertainty. You know, people have had bad experiences in the past, so therefore doing something new, doing something innovative, it could be painful. Bias. Do you notice anything kind of that all of those things have in common? Sorry? No?
Small c, conservative.
Conservative, yes. Emotional, close. They're all people related. They're all related to humans. And we've seen as well, humans are complex. Okay? Which is why, when we talk about, you know, I regularly go into customers and talk about you know, their sustainability problems, what we can do about it, and we talk about, naturally, in clean rooms, we talk about air change rates and HVAC optimization, and we show them the data that we've did the experiment on, and we show them a load of case studies that proves it, and it's been demonstrated in practice multiple hundreds of times. And then the answer is, yeah, but we're quite special here. We're quite unique in what we do, and I know it kind of works somewhere else, but it's not. I don't feel it's right, or you know, we haven't got any time in the to do anything innovative in our facility because we've got no time. We haven't got shutdown capabilities and all of those things. They're all kind of human related, maybe. Okay. So, how do we solve that? The last point I make is that if you're looking at it above the surface, we see clean rooms as complicated. But actually, they're complex. And actually, they are complex systems, but we're acting like they're complicated. And we're not addressing this below the water level stuff. So, my thoughts are, it'd be interested in your thoughts, is exactly that. Clean rooms are complex systems, but we're acting like they're complicated. And therefore, if you're looking like here, you're saying, well, if I do this, I'm going to have this outcome, aren't I? Of course I am. But unless you consider this, you're gonna come a cropper, essentially. So when I reflect on what type of clients that we work with in my business, in our business, in broad terms, they kind of break down into two groups. I'll show you those two. So type 1 customers, they're only looking at that top of the iceberg, tip of the iceberg, right? So, and the problem with that is that they want to know the outcome of things before they even start. But as we've shown, that, okay, if you're only looking at the top, yes, you can predict the outcome, but if you're not looking at the whole, then there's still a huge level of uncertainty in there. And what that leads them to is they measure the outcomes or success by the failure and not the learning that's gained part of that, or the successful failure. And that leads to slow in innovating, slow at doing things, getting stuff into. And you know, they achieve some results. You know, it's okay. We do some stuff together, but it's not perhaps as good as it could be. The type 2 customers, they're prepared to experiment, because the only way to understand that stuff below the surface is to experiment. It's to try stuff out, learn, adapt, try some other stuff out. And it's not, you know, I'm not saying do this in a live GMP facility, right? Because that'd be really difficult and not advisable. But there are ways of doing it. There are ways of testing stuff out, trying. And the best thing you can do is you get the people that are here to join in that experiment. Go on that journey with you so that you learn together and you come up with the right answer for that company, that organisation, that site. So type 2 customers are great. They understand this because they're looking at the whole. They measure the outcomes by the learning and the progress towards their goal. They recognise that innovation is not easy. It's a bit messy. It needs to be controlled, obviously, in a regulated environment, but they do stuff. They adapt and they innovate more rapidly as a result, and they achieve much better results at the end of the day. So, back to your point about HVAC dynamic clean rooms, spaces, the innovation, technology works. It's been in Cambridge Pharma for quite a number of years now. The data's good, the facility work, the technology is reliable, robust. We're just doing another one at the Medicines Innovation Centre up in Glasgow. Again, we've had the technology in our test facility for 6-7 years, and it's solid, it delivers results, no problem. It's all the below the water stuff, or below the water is where some of the differences need to be realised. But these organisations, they're type 2 companies. They're type 2 customers, so they are innovating. And we've got loads of others in progress. There are lots of people doing this stuff. Air change rates, going back a bit, dynamics is great, but there's some basic stuff that could be done way before you even get to dynamic. So we've done over 1,000 kind of assessments and study and so looking at efficiency and air change rate reductions on sites all around the world. Hundreds of feasibility studies that say, okay, yeah, if you do this, this will happen, and we can assure it, and it's good results. And probably less than 50 have actually done stuff. Why is that? And all of the ones that did it successfully, and it worked and delivered some great results. So that's the question in my head. So I'll leave us with some final thoughts. So innovation's really messy. It's non-linear. It requires curiosity. It requires grit, and a willingness to fail and try new things. But if we don't do that, we won't progress, or we won't progress at the rate that we need to solve some of these huge challenges of sustainability and climate change and everything else. We're part of that. I tried something different today. I innovated with this presentation today. I wasn't sure about it. Honestly, if you speak to some of my colleagues, it's kind of, should I do this, should I not? But I did it anyway, and if it had bombed, great. I'd love to hear your feedback on that, and it'd be great, and I'll have learned something from that experience. If it was really positive, you liked it, great. Let's continue that conversation and see what we can do. And I hope you got something useful out of it. So thank you very much for your time, and I'll open up for discussion.
Thank you, Keith. That was really good. Show of hands. Was it good? Was it a success? Or was it a face? Show of hands. There you go.
Thank you. Thank you very much.
Any questions for Keith? Must be some questions on this. Well, thought you might.
I thought you might, Gordon.
Can you sit near at the front, Gordon? There you go.
So, really enjoyed that angle, Keith. Just go back to motivation. So, life science, very different from semiconductor because it's driven by BS, regulatory stuff that's not based on science. And the industry is petrified about non-compliance. If you move to the semiconductor industry, they're driven by yield of product and profitability and reliability of the device that they're making. So the different motivations. And you can't make today's semiconductors with processes that are 5 years old. So there's a continuous cycle. We can make sterile products in a 40-year-old factory. using knackered old air conditioning systems that are falling apart. I'm exaggerating slightly, but we're in a very different environment. But just thinking about some other motivations, question for you. Have you thought about or discussed no win, no fee approach? So you evaluate, let's assume it's an existing facility which you're doing a retrofit, energy reduction or carbon reduction, and the basis of remuneration is 50-50 share of the CO2 you save or the energy you save during the first 5 years of operation. Have you ever do you think that would have a different motivation?
So we do that. In fact, the MMIC, the Medicines Innovation Centre up in Glasgow, we have that kind of arrangement, which is they are paying for the technology based upon the savings delivered. Okay, very straightforward. I'm going to say it anyway. The pharmaceutical industry is not short of money, honestly. So if they wanted to do stuff, they would. So I don't think whatever funding mechanism is the barrier here, actually. I think it's more, there's some other stuff that's going on, other stuff underlying. So I think that would be my view on it. So, of course, if that was the only barrier, that's an easy problem to solve. But I don't think it is.
Okay. Any more questions? No? Yep.
Yeah.
I think that the pharma industry is probably more conservative than maybe electronics, because if we get it wrong, it's devastating. And we are where we are now, and there's a resistance to change because we know it works. We also know that our detection systems are not sensitive enough to tell us everything. So as well as the known unknowns, there are lots of unknown unknowns. And so we're happy to work where we are because we know it works. So to shift our thinking and to shift our controls takes someone very brave. And that's where we are, I think, anyway. So I think it's the, show me the beef. Does it work? Does it really control? What about in this circumstance? What about in that circumstance? And that's what the regulators will ask us. How do you know? You've got years of history of the other way. This is a bit, ooh.
Yeah, I'll take your point. What if it was better? What if it was better and it provided you more certainty, more reliability, that you would create the right environment than what we're doing today?
And that's something in the NHS is we're getting asked all the time, especially by our sort of board, trust boards, is that they say, well, you want all this money, but it's going to cost how much to run a year? Can't you switch it off at night? And those are the things. They're looking at energy efficiencies and so forth. We said, no, it needs to be running full for pelts. And so it's this sort of thing that we do need, particularly in areas of pharmaceutical industry that don't have the money. But, I mean, I think Big Pharma do have the money, but it's would their shareholders accept the risk? Yeah.
Yeah, so you're in NHS. So my wife works at the NHS, actually, quality improvement being in a hospital, and we were talking about this stuff, and they innovate all the time. They do stuff really close at the patients, right? They're doing this stuff all the time, and it touches people's lives quite, but they have to do it in a safe way. They have to do it following the right processes so that we don't. It's not about putting patients at risk. It's about the experimentation is about understanding where those risk boundaries are, so that you can understand what you can do or what you shouldn't be doing.
Yeah, like even with new treatments, is this pathology? Is it a clinical trial? Just the regulation of it would be just to look at use of phages for treatment. So we're thinking, well, it's not a medicinal product. it's not, is it an API? It's not regulated at all. So it's like, well,
Yeah.
do we not bother with that? Give it to someone, a clinician to manage, and goodness knows how they do that, or do we bite the bullet and do it ourselves? So it's at all aspects of the thing. And yeah, so we're resistant to change because we know there are too many unknown unknowns as well as the known unknowns.
I think the resistance to that is your whole thing is exactly right. If you look at clean room facilities, how many of them do setback when it's empty all weekend? So very, very few systems I'm aware of, organisations I'm aware of, do setback. That simple kind of slow everything down when there's nothing going on, there's no one in there, there's no contamination, no source strength. Why do we need to pump all this air around? So few people do it. And I think that's just that resistance. I think you're right. There's no absolute.
And where's the risk there?
Yeah, exactly. Where is
anything.
the risk? But people don't do it.
So we need to bring regulators into the conversation, because we're not going to innovate and get better if we don't have them in the conversation and in that experiment, so we can understand the complexity and do things differently.
Okay. Any more questions? No, thanks.
So I think we alluded to this a little bit yesterday when I think maybe you, from NHS perspective, were talking about design and the effort. You need to do proper engineering design of an innovative system. You can't wing it and do well, you might do if it's an exact me too to one that's already been proven. But you need to do proper, we're talking about the environment, the clean room environment. You need to do proper calculations. You need to do proper fan sizing, ductwork sizing. If you keep it incredibly simple without setback of volume, you can probably guess it without doing any design. And that occurs because very often, not only in this country but around the world, the procurement is done on a very cheap basis, and nobody's got the headroom to put the man hours in of the right level of competence to do the design. Yes, and you end up with, I would suggest, poor design and poor execution. So it's not just the design, it's actually the execution is poor, no technical oversight on quality, and you slide into a mess, really. So that's probably where the rot starts.
Are we only now just getting NHS Trust to realise that you do need a clean room specialist? Estates right above the builder cannot build a clean room just because it's very specific and often does not mean it can build ISO 14614. And so it's because there's been so much bad experience.
So do you think we're kicking out of that in the health service slowly?
Yeah, because we've demonstrated that actually if you spend cheap, you spend twice.
Right, okay.
Great.
Thank you everyone. And any more questions? We've got time for one or two. No, we're done. I think that was great, Keith.
Thank you.
Really energised everybody. That's really good.